Okay. Let's see. I would like to make or let me show you here how my over unity high frequency resonance transformers work, and I'll go over that here in the circuit. Let's see. This is basically how the system works. You can run the system off of a 12-volt battery and an inverter to bump the system up to 120 volts. In this case I'm running it off of the wall, but this is still, and then I run it through a compact light fluorescent circuit. This uses a high frequency to drive compact lights, compact CFLs. In this case I have it running to the primary coil on our flyback transformer. You can just test the continuity of the pins, and the one with the highest readout is going to be your primary. These flyback transformers have a built-in diode, which I'm showing you here. There's a high voltage diode. It's 30 kilohertz or more diode, because these transformers can put out on the order of 30,000 volts. So here we have our homemade foil capacitor and our spark gap. Here's our ground or not ground. It doesn't really matter in the circuit right now. The system is set up for perfect resonance, so it actually doesn't even need a ground or any of that. Basically you have your step-up transformer here with a center tap, which is connected identically to your identical step-down transformer. The center taps are connected, and a earth ground is optional but not needed. These two are connected directly across. In this case they're just wound. I have the schematic open for options because I've been working with different ways, but right now these are all just connected straight across. That's how the system works. Then there's a step-down coil on the opposite side for stepping the voltage up and then stepping the voltage down. We have our full wave bridge rectifier, rectifying the alternating current coming from the step-down transformer on the opposite side. And then we have our high voltage pickup capacitors here, and this is our high voltage out. So that is how the circuit works. Now I will show it to you here. Basically what you see in front of you are the two resonance transformers. They're basically identical. In this case they're basically identical. So I'm going to show you how this works. Let's see, I'm going to hook up my multimeter. I'm going to hook up my multimeter to my capacitor bank here. Now the multimeter only goes up to 600 volts, and the system actually puts out more than 600 volts. So I can charge the capacitors up to 600 volts, and then I have to disconnect the multimeter, but I can continuously show you the amount of current coming out of the system. So right now I have my multimeter hooked up to the incoming cord. This is the incoming off the wall cord. It's 120 volts. It's 120 volts at approximately 0.0 amps to 0.1 amps, a tenth of an amp to 0.0 amps. So the amount of current coming into the amount of current being used by our compact light fluorescent circuit is anywhere from 9.6 or 10 out to 12 or 13 watts. So it's not a lot of watts going into our system. There's our CFL, that's our flyback transformer. We have tested the negative pin on the flyback transformer by using a positive voltage of, say, 10 volts or more to test positive current through there. Otherwise you can't test it because you the diode won't let the circuit work. So you have to have positive voltage. There's our homemade foil capacitors. There's our tuned spark gap. The spark gap does matter in the resonance circuits because the amount of spark that, or the larger the gap, the amount of voltage that crosses. So the smaller the gap, you can tune the voltage that way. So we'll turn it on. Let's see. And okay, we have it on. We're at 400, 500. We're at, oh my gosh, 600. We're at over 650 volts, and we are pumping that in at 0.09, so right around 10 watts. That's our incoming current. If we connect it to our outcoming line here of alternating current coming off of the outside, we have approximately, it'll jump around, but we get right now we're getting 1.7, 1.6 is usually what I was getting. I was getting 1.2 earlier, so we're getting quite an increase. If you check the current here, we were getting 1.2 amps before coming out of the circuit at 600 volts. So that's approximately 720 watts of outcoming electricity coming out of the circuit. And right now we're putting out 1.5 amps, and we're only drawing, we're putting 1.5 amps coming out, and we're only drawing 0.1. So the system is stepping up over 10 times the amount of electricity that we're putting into it, therefore creating over unity. That is my device. Thank you.